Ladies and gents, welcome back to another Engineers podcast. Today I'm joined by Alexey Lipitsky, who's head of engineering for Aurora Labs. Aurora Labs, the development company behind Aurora. So essentially, they're the EVM blockchain that runs on the NEAR protocol. We've got a really interesting pod with Alexey, who's going to be talking to us all about the NEAR protocol, some of their engineering challenges inside of Aurora Labs, and some of the use cases of these protocols, and essentially, what they're building this stuff for. So we're lucky, we're fortunate. Alexey, thanks for coming to join us. Do you want to give us a bit of an intro into your background?
Thank you. My pleasure to be here. A couple of words about my background. I have been an engineer my whole life. Started in the site reliability space, then switched in the past few years to the security space. And at the end of the journey in my traditional Web2 career, I realized that the security of Web2 space it's more compliance-oriented than I wished. So I decided to switch to the blockchain, to Web3. And of course, security is a core product of blockchain. And spent basically 2 years working on securing our ecosystem. And in the past year,
yeah, nice. Talk to us a little bit about that transition from Web 2 to Web 3. I've had a couple of people on the podcast now who've gone through that transition. Really keen to get your perspective on it as well.
So when you work in security, one of the first things you realize is that it's for the traditional Web2 space, it's mostly a support function. So you have the business direction, and your goal is to basically do everything possible to make it safe without slowing it down. And of course, there are a couple of compliance angles. And the interesting part is that for big companies, if security is not their core product, security doesn't matter that much. If you see at big hacks in the past, like Equifax or LinkedIn, it doesn't really affect their businesses that much, not even the stock prices. And you start noticing this, and you start asking questions like, why is that? Why doesn't market care? And then you look at the other direction, let's say Web3 security. And there it's a question of business continuity. If you lose customers' funds, you're out of business. And there is rarely a way back. So yeah, that was basically the deal breaker for me. And that's why I switched.
That's quite an interesting perspective. I never actually thought of it like that. But really, the companies that we've been speaking to in the Web3 space, their businesses and their trust with their customers, security is the foundation. Security is pretty much what everything else is built on top of, and it drives your business. It's like the nose of the business. So I never really thought of it from that Web 2 space, but that makes a lot of sense.
Yes, it is indeed. Maybe one additional lesson, which applies everywhere. It doesn't matter how big you are. Your size and your popularity, it's not really a good proxy metric for how safe you are. So even now you see all of the big companies, products that everybody uses, their security posture is just embarrassing, to be honest. And extremely popular web apps, browsers, like get hacked for reasons which could be just classified as negligence, basically.
Yeah, okay. Talk to us about Aurora Labs. You guys are doing some sexy stuff. Give us the elevator pitch, if you like, to Aurora Labs and what you guys and girls are doing.
Before I speak about Aurora, I have to speak about NEAR and what it is, how it works, and why it exists in the first place. So to continue the Web 2, Web 3 metaphor, so to say, I think Ethereum ecosystem, which dominates the market right now, it's kind of similar to JavaScript ecosystem. So you're basically you become the first big player on the market. You gain a lot of popularity, and there is a huge network effect. So everybody starts using it. Absolutely everybody. So development frameworks are being created, libraries, all of the different primitives, and of course, all of the big players, they start integrating you into their ecosystems as well. So Ethereum has this huge advantage. But if you look back, there are a couple of design decisions that were made, which makes it hard to evolve and scale. And of course, like the most common problem people talk about is Ethereum gas fees and Ethereum scalability. So there was this design pattern that was implemented in Ethereum that basically, as a programmer, you see the Ethereum state as a synchronous snapshot you can operate on. So it hides this complexity from you. So you just execute transactions. If you're not happy with the result somewhere in the middle, you roll it back. You can interact with the whole Ethereum universe in a single transaction. There is no limitation whatsoever. And on the one hand, it's extremely simple. On the other hand, it's not how our reality works. Our reality is fundamentally asynchronous, and there is a limit to how much you can scale such a system. And if you want to solve this problem, of course, you have to make sure that all the existing source code continues working. All the existing bytecode keeps working. So the problem that Ethereum is trying to solve, it's extremely complex. So, and because of that, it's moving maybe a bit slower than we want. And this problem, it gave birth to the next generation of blockchains, which basically take a different trade-off, and they expose this complexity to the smart contract developers. And when they interact with other smart contracts, they interact in an asynchronous way. And of course, they have to handle all of this uncertainty which comes with this asynchronicity. Unfortunately, this complexity makes it really hard for the existing ecosystem to adopt it. So when the NEAR ecosystem came to be, there was a question: how do we make it work with like the dominant ecosystem on the market, which is EVM and Ethereum? And that's how Aurora came to be. So Aurora is a smart contract on top of NEAR network that implements execution layer of the Ethereum ecosystem. So we don't need to solve any of the consensus problems of Ethereum. It's solved on the lower level by NEAR network itself. But the business pitch for Aurora is to make it as compatible to Ethereum, to EVM as possible, and make the migration as easy as it could be. And of course, there are two components to it. There is an on-chain component, the execution layer, but also the RPC itself. So it needs to be compatible with all of the existing wallets, all of the existing indexers, and we had to solve this problem as well. So right now, Aurora, it's basically two networks, Aurora mainnet and Aurora testnet, which are fully Ethereum compatible. And recently we started a new direction called Aurora Cloud, that allows us to deploy smart contracts for anybody who wants to have their own networks with their own rules, let's say base tokens, gas fees, and stuff like that.
I've got this image of my mind of Lego bricks and its layers of compatibility. I don't know if I'm wrong, and please tell me if I am, but that's how I'm making sense of this. You've got a network, the Ethereum network, and you've got the different protocols and different layers that you're allowing compatibilities into one another. If I am wrong, of course, like demystify it.
You're absolutely right. So there are so many components that are required for a DApp to work. So if somebody wants to create a business on chain, of course they have like the products they develop, but they have to solve a bunch of problems which come with it. One common problem is to have, let's say, safe access control of the smart contracts. And to do that, you need to have a good multi-sig solution. Multi-sig is basically a way to make it safe to, let's say, require 3 signers out of 5 to upgrade the smart contract. And it might look easy to implement it, but that solution has to be extremely safe and extremely resilient, because if you lose your access on chain, there is no way to recover from that.
Yeah, I bet.
Yeah,
I bet. We're going to go into a couple of different topics today. I want to try and break some of those down and understand day-to-day challenges. I think it'd be a good place to start high level. What are the most important components that actually make up Aurora? Can you break those down? And then we'll just layer it, ironically.
okay. So let's go from the bottom level to the higher level. So the bottom layer is, we can say it's near runtime. So near ecosystem is a foundational piece for Aurora engine. Why is that? Because from any level above, you can interact with the whole ecosystem from Aurora smart contracts. You can make calls into other engines, to other smart contracts, and the features that are being developed inside of near core, they get automatically exposed to inside of the EVM networks. One example is MPC, multi-party computation. So this feature was shipped recently to near and near core, and it became automatically available to every single Aurora engine on the network, with basically no effort from the higher level. Yeah, so near core is the foundation that we are using. On top of that, the smart contract consists of multiple parts, and maybe the most interesting part, it's called EVM interpreter. So to ensure, there are 2 ways to run EVM bytecode. You can either compile it or to interpret it. EVM bytecode is very different from WebAssembly, and it's an extremely hard task to translate EVM bytecode to WebAssembly. We tried doing it a couple of times, and we decided to abandon this idea. So
what's difficult?
Basically, of course, why would you compile to WebAssembly instead of interpreting EVM bytecode? Because it's much faster. Yeah, it's basically at least an order of magnitude for an average smart contract. But the translation between EVM bytecode and WebAssembly, it's not straightforward. There are a couple of algorithms that can do it. But ultimately, there is uncertainty that cannot be eliminated, that this translation will be 100% compatible. And because of that, there is also a bunch of security risks and stuff like that. Instead of solving the problem of translating EVM bytecode to WebAssembly, you can also just compile Solidity to WebAssembly directly, just skipping EVM bytecode completely. And that's an idea that we might implement in the future. The speed up we expect to be like even higher than the translation approach. And the source code is often available because people who are running smart contracts, they verify them. They basically upload the source code to the explorers, and it's possible to compile them. And there are open source solutions that solve this problem, of course. So potentially we will evaluate this approach as well. But for now, the fees on the neural network are quite small anyhow, and we are not hitting any performance bottlenecks. And because of that, we are continuing using the EVM interpreter, which is basically a core piece of technology that always has to be involved. So Ethereum, it's not a stationary ecosystem. So Ethereum mainnet always evolves. They always invent new transaction types, new opcodes. So we have to follow it because that's our business proposition. We want the Ethereum ecosystem to be able to migrate to near and with zero friction. On the one hand, it's a pretty complicated problem to solve to maintain this compatibility. On the other hand, we need to maintain only compatibility of the execution layer. So all of the changes that are being introduced in the consensus layer, I mean, it's solved for us already on the neural network level. So it makes our life a bit easier.
It's interesting as well that the industry is open sourced. The industry is learning about pain points with people building solutions, building on top of layers, and the feedback loop seems as if it's quite fast to really iterate on those and find solutions. That's how the networks are evolving, and that's how it's making all of this interoperable. So it's good to see in that sense. That's what I pull apart from what you're telling me. I think it would be good to touch on virtual chains and why these are important for you. We've obviously understood the technology makeup of Aurora Labs just then, but talk to us a little bit about virtual chains.
Mm-hmm. During last bull market, we launched Aurora mainnet and Aurora testnet. So those are public blockchains which use Ethereum base token and that follow Ethereum mainnets when it comes to compatibility. So their objective is to work pretty much the same as the Ethereum mainnets. Many people know that in the past, people thought that there will be one blockchain that will win everything and will get all of the market share. Now the consensus has switched. So people believe in upchains and in the multi-chain future. And once you have your own upchain, it opens many opportunities for you. Let's say you are a business, and let's say you are a traditional Web2 business, and you would like to go to on-chain. But your customers, let's say, they are not familiar with Web3, and you would like to minimize their onboarding experience. So you need to minimize their friction of starting using blockchain. One of the most common friction points is the first one is on-ramp. Let's say a user has a credit card and they want to start using the chain. The second one is paying for the transactions. What we are trying to solve with upchains is that this problem of on-ramping users could be moved to the shoulders of the company that is provisioning the blockchain instead of the end users. So if you're a company and you want your users to start making transactions, we allow companies to basically pay for these transactions instead of the users paying for them. That's one example. Another example is if you are a company that wants to trade, let's say, real-world assets on-chain, and you want to be compliant with regulations like anti-money laundering, any sort of regulations, we provide a way to be compliant. Basically, the company can enforce who can connect to the blockchain. It can enforce if people go through the KYC, sign relevant papers, while still providing a Web3 native experience so that people have full transparency how the trades are happening, and they see explorers and they use Web3 primitives with an additional level of protection for the company and for the end users. And of course, the business pitch for Aurora Cloud, why is it better than all the alternative L2 solutions? So first, it's compatibility with Ethereum. So we support all of the precompiles, all of the Ethereum, pretty much all of the Ethereum opcodes. The cost of deployment of this chain is extremely low. So we don't need to take care of the settlement layer, of the consensus layer. Everything is already solved by near blockchain. And what we do provide, when we launch a new virtual chain, everything that is available to the near ecosystem, it's available to you from block 1 immediately. So all of the existing oracles, multi-sig solutions, on-ramp solutions, you can use all of that immediately without too much overhead.
Got you.
And
Okay.
That's a pretty big differentiator.
No, that is a pretty big differentiator. I think what I know we're going to be speaking about is a little bit about that developer experience, but I also feel an important experience to think about is the customer experience as well. And you touched on ramping and ensuring that you're providing a really seamless experience. I know about on ramping because I've spoken to different businesses who've adopted a similar approach to onboard people onto the network. So it'd be really good to understand how Aurora Labs are thinking about customer experiences and developer experiences as well, and why you're building things in a certain way.
Let's start talking about customer experience or end user experience first. So usually what when companies provide like this layer 2 solutions or blockchain solutions, besides this on-chain component, there is also an RPC component, and there is a lot of cost involved in running the RPCs, running the indexing solutions. And because we are doing it at scale, we are doing it horizontally, we are launching many app chains. It allows us to solve these problems at scale, horizontally, basically, and make use of all of the existing automation that we have. One of these technologies that we're applying to everybody, in simple words, you can call it off-chain blockchain. Basically, we are keeping state of the blockchain network, of the distributed near blockchain network inside of our data centers. So there is a continuous synchronization pipeline of all the blocks produced by all of the Aurora engines everywhere that is continuously being applied to the microservices, to the microservice databases inside of our data centers. And these microservices, what they allow us to do, basically two things. First, give extremely fast replies from these microservices without going to the network, but also to emulate these requests. So there are basically two paths, read path, when you need to read data from the blockchain network, and it's possibly like 99% of all requests are read requests. It's extremely important to view this data really fast and to minimize cost of this, of reading this data. And the write operations, they could also be quite costly if you make a mistake. Let's say if you send a transaction that cannot be executed, it's just bad UX, and if you send it to the near network, you pay money for it, even if it fails. So what it allows us to do, this microservice, which synchronizes this blockchain state continuously, it allows us to emulate transactions before we send them to the network. And we can do it very, very fast and provide very good user experience. So this service, basically, it optimizes for two things: for the end user experience and for the company or customer experience, to minimize costs, to improve speed. And that's one of our know-hows that is significantly different from how everybody else is doing it. Another differentiator is Aurora Cloud Console. It's a portal that allows customers to control how they're using their blockchains. So our approach right now is to solve problems as they come from our customers. Let's say a customer wants to launch an upchain, and they would like to have an oracle, like one specific oracle. We had an example when a customer just wanted to have CoinMarketCap stats on chain. So we solved this problem once, and once we have this solution, because all of that is using exactly the same technology on the same consensus layer, we can deploy it for anybody else. And we platformize the solution and we expose it to all the other customers. And same goes for on-ramp. So same technologies that are used to, let's say, onboard users and bridge tokens from one place to another, all of them could be made accessible to customers from block one, basically.
Got you. Okay. You touched on something quite interesting. And this was maybe one or two questions ago, but I'm really keen to understand where you're standing in terms of technology and adoption at the moment, and how that might compare to other people in the market as well, and what you're doing to stay ahead of the curve.
So to stay ahead of the curve, of course, our table stake technology is compatibility with Ethereum. So this work never stops. So right now we are working on Prague support, for example, which is to be released in the next few months, hopefully. But what we are providing is a superset of Ethereum functionality. What we are providing is basically we are extending what Ethereum can do by exposing an interface towards the rest of the near ecosystem. And we have implemented, for example, the first version of an interface called cross-contract call, where you can call a different near contract from inside of the EVM and basically, let's say, make a trade on the near liquidity pool instead of Aurora liquidity pool. And there are a lot of primitives that are related to this interface. For example, how do you interact with the MPC? How do you make it easy? Not just possible, but easy and developer friendly to do so. So innovation in this space is one differentiator. Another differentiator is that we, like this table stake technology of compatibility, it's not that simple. So one thing that we are doing that is different from everybody else is that we are applying all of the available integration tests that are available for Ethereum mainnet to our own engine. And that's the first level of compatibility testing that I'm not aware that anybody else is doing, but we have invested quite a lot of resources to make sure that every single test is being executed successfully on the engine. So that's part one. Part two, we do compatibility testing with all of the libraries that are available. So we're testing with JavaScript frameworks, with Rust frameworks that interact with the RPCs, and we make sure that all of them work all of the RPC. It's not just the execution layer itself that we have to make compatible, but also the RPC layer as well. So a lot of work is being done there. On top of that, we are innovating in this space even more. So our ambition is to emulate all of the Ethereum transactions on the mainnet inside of the Aurora engine on the Near network. So what we're thinking about doing is to start Aurora Cloud instance that receives every single transaction from the Ethereum mainnet and produces exactly the same identical blocks. And I'm not aware of anybody who has the same ambition or who is doing the same.
You're obviously innovating on some of the technology that you've already built, and you're making bets on the future. How do you see some of the chains evolving over time? Because they've evolved from where we've been speaking about over the last few years.
So the evolution of the chains themselves, I think it became a bit of I don't want to say a secondary topic, but the new narrative in the blockchain ecosystem is chain abstraction. That you just don't care about the chains. You have, let's say, your DApp that can interact with everything everywhere. And there's a whole bunch of dexes and apps which start working on chain across most of the chains pretty much immediately. And of course, it's possible right now with players like Binance. Like, okay, you have a product that works everywhere, it's fine. The challenge here, of course, is to be decentralized. How do you make this chain abstraction functionality truly decentralized? And the answer that everybody is looking at is multi-party computation. So most of the blockchains right now, they're adopting some sort of multi-party computation solution, including Near. And this solution allows you to basically sign transaction without having direct access to the full access key. So, and you can change who controls this account or address by making on-chain transactions. It allows you to implement a primitive like account file. Basically, let's say stake a bunch of Ethereum to Lido, and then give this account to somebody else without unstaking, without making any transactions on Ethereum itself. So, and of course, one example is NFTs. Let's say if NFT implements some sort of royalty business logic, when it changes your ownerships, you can completely work around this business logic by applying these MPC primitives and just changing custody of this account without making the actual on-chain transaction on the Ethereum network. So this is a disruptive technology, which I think we haven't realized how it will impact the whole DeFi landscape.
Interesting. So technology is evolving. You're understanding how to best use it. How are you making bets on where the business will be growing in the future and what you'll be hiring for?
So we are trying to innovate in the chain abstraction space. So there's a new product that we're launching that makes use of the MPC chain abstraction primitives. But I will not talk about this on this podcast, maybe later. But of course, we are pretty much aware of the narratives. And yeah, chain abstraction is one, and artificial intelligence is a pretty big another one. So we'll see. Maybe we'll do something in the AI space as well. But of course, the idea is to make use of these technologies and make them accessible to the Aurora Cloud customers immediately. So every Aurora Cloud customer will benefit from these innovations.
Yeah, okay. Smart. Talk to us about how the business will grow with some of the ideas that you've got about introducing the technology and AI as an example.
So the business itself depends if you're talking about Aurora ecosystem or Aurora Labs as a company. So
Aurora Labs as a company.
of course, our goal is to attract companies which are not Web3 native. So that's one area, and it's there are a lot of opportunities. Basically, all of these traditional Web2 ecosystems, they could be using blockchain. They just want to have no user friction and no friction for themselves to use them. And I think we are in a very good position to solve most of the problems for these companies and attract them to blockchain. And once you have end users and these companies on chain in the near ecosystem, then you start getting network effects. So all of these people and companies, they can start using their own platforms. Let's say if somebody implements hub for trading real world assets, and the users who are using this hub, they will benefit from more real world assets appearing on this platform. So, and of course, there could be plugins and additional solutions which benefit all of these players in the same space.
Good. Okay. And talk to us a little bit about the growth in terms of hiring people. Use this as a shameless plug, if you like, to be able to say to our engineers ecosystem, these are the types of people that we're looking to attract.
We engineering wide, we have 3 areas that we are hiring for. The first one is the apps team. So the apps team is developing solutions for the Aurora Cloud customers, and these solutions, they involve developing Solidity smart contracts, sometimes developing web portals, but basically discovering what the customers need and then platformizing these solutions for everybody else. And the skills here are Solidity and traditional full stack development, like React, TypeScript, stuff like that. The second area is infrastructure. So these microservices I was talking about that make RPC compatible and fast, most of them are developed in Go. And the biggest challenges that we're going through right now is scaling this infrastructure from 2 independent networks to N. And this N could be quite large. So it's not just a problem to provision it, but also to maintain and operate and upgrade and to make sure nothing breaks. So making this change from 2 to N, it's an extremely hard task. So we are hiring for an infrastructure team, basically site reliability experts and Go developers who can help us with this transition. And the third area is protocol development. So Rust developers who are not afraid of basically getting head down into a near ecosystem and creating super performant smart contracts, of course, super safe. We are always looking for talent in this space. So yeah, it's one of these aspects of the smart contract development on the near ecosystem. It has to be Rust. It has to be, safe and fast and performant.
Okay. For people listening who are in apps, infrastructure, and protocol development, you've clearly got a smart guy here in Alex, who's obviously super interested about what's happening in the blockchain involvement space, especially in the near protocol. And I think Aurora Labs, we've seen a stellar performance from Alex talking to us a little bit about what they're doing, why they're different, what they're building, and where they're making their bet. So I want to say a massive thanks, Alex, for coming to talk to us, share with us about what you're doing, what you're building, and how you're building it. And where you think you'll be going in the next 12 months.
It was my pleasure. Thank you so much.
Absolute pleasure. And for people listening, likes, shares, subscribes, they contribute to this little ecosystem that we're building. So please continue to do that. And all the info that's on Aurora Labs that you need from what we've spoken about in this discussion will be below for you all to check out. So a big thanks. And thanks, Alex, and bye for now.
Bye-bye.
Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Enginears is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Enginears.io. It's no_. We've also got a website which is engineers.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.